The complex number z is defined as z is cosine of theta plus I sine of theta. Question A shows that z to the power n minus 1 over z to the power n is equal to I multiplied by sine of n theta. So, since we can see that there is a complex number raised to some power, we know the Demarche theorem formula is given in a data booklet, and it says that a complex number which is given in a modulus argument form are multiplied by cosine of theta plus I sine of theta, where I is the modulus, theta is argument, and when complex number is raised to the power n, it becomes modulus to the power n multiplied by cosine of n theta plus I sine of n theta, and we can use this formula here to get z to the power n minus 1 over z to the power n, and it becomes z to the power n, and this we should represent z to the power n to be in numerator, which is what, just z to the power of negative n. And now we can apply the Demarche theorem, and z to the power n becomes, notice that here modulus is 1, so it just cosine of n theta plus I times sine of n theta. This minus, and again the Demarche theorem for z to the power negative n, just substituting negative n for n, we get that it's cosine of negative n theta plus I sine of negative n theta. And cosine, it's even function. It means that function of negative x is equal to function of x, and sine it's and also tangent are odd functions. It means that function of negative x is negative function of x, and using this we can rewrite it as cosine of n theta plus I sine of n theta minus cosine of n theta minus sine of negative becomes just minus sine of positive, so minus I sine of n theta, and it becomes cosine of n theta plus I sine of n theta minus cosine of n theta, and plus I sine of n theta, and it's clear that cosine cancels and we get 2I multiplied by sine of n theta as required. The next, use the binomial theorem to expand z minus 1 over z to the power of 5. We need coefficients, and let's consider coefficients 1, 1, 2, 1, 1, 3, 3, 1, 1, 6, 4, 4, 1, 1, 10, 10, 5, 5, 1, 1. And it's for the second, the third, the fourth, the fifth power. So we'll use these coefficients. Let's rewrite 1, 5, 10, 10, 5, 1, and z minus 1 over z to the power of 5, and we should consider it as z plus negative 1 over z to the power of 5, and then coefficient, the first term it may be to the greatest power, or it may be to the power of 5 or to the power of 0, it doesn't matter. Let it be to the power of 5, then negative 1 over z will be to the power of 0, then coefficient, next coefficient is 5, this power decreases by 1, this increases by 1. So it becomes z to the power of 4, negative 1 over z to the power of 1, plus 10 z cubed negative 1 over z squared plus 10 z squared negative 1 over z cubed plus 5 z negative 1 over z to the power of 4, and finally plus 1z to the power of 0, negative 1 over z to the power of 5. Let's check. 5, 4, 3, 2, 1, 0, 0, 1, 2, 3, 4, 5, 1, 5, 10, 10, 5, 1, correct. So let's simplify. So it becomes z to the power of 5 minus 5z cubed plus 10z minus 10 1 over z plus 5 1 over z cubed and minus 1 over z to the power of 5. And you can see that there are z to the power 5 minus 1 over z to the power 5, and we can use again the same formula, and it becomes 2i times sine of what? 5 theta. Then you can factor out negative 5 and we get z cubed minus 1 over z cubed, which is what? 2i. So it's, let it be 5 times 2i and times sine of 3 theta and plus 10 times 2i times sine of theta. But on the other hand, z minus 1 over z to the power of 5 can be considered as z minus z to negative 1 and then to the power of 5, and here we can apply again what the de Moivre theorem to rewrite as cosine theta plus I sine of theta minus cosine of negative theta plus I sine of negative theta and then to the power of 5. And it becomes cosine plus I sine, and again cosine is even function, so it's just cosine of theta, and this is minus, so minus cosine of theta, sine of negative, it's a minus sine, this is minus, so finally plus I sine of theta and to the power of 5, and you can see that it becomes 2i sine and to the power of 5, and it's 2 to the power of 5, which is what, it's 32, and I to the power of 5, it's I to the power of 4, which is I squared, and I squared, it's what, negative 1, just by definition, so it's 1 times I, so it's just I, 32i sine to the power of 5 of theta, and since it's the same z minus 1 over z to the power of 5, so we can equate our results, so we can write that 32i sine to the power of 5 of theta is equal to 2i sine of 5 theta minus 5 times 2i sine of 3 theta. I don't multiply because I can see that that I can divide by 2, and plus 2 times 2i sine of theta, and you can see that we can divide by 2i, we can divide each term by 2i to get 16 times sine of theta to the power of 5 is equal to sine of 5 theta minus 5 sine of 3 theta, yes, 5 sine of 3 theta and plus 10, yes, 10 sine of theta. The next, check that your result in C is true for theta is pi over 4. So let's consider this. It's question D. d So theta is pi over 4, and the left hand side becomes 16 times sine of pi over 4 to the power of 5, and pi over 4 is 45, and it's root 2 over 2, or 1 over root 2. To the power of 5, and it's to the power of 4, and just 1 over root 2, and to the power of 4 it's squared, so squared it's a half, and again a half, it's 1 over 4, so it's 4 over root 2, or 2 root 2, if we multiply numerator and denominator by root 2. And the right hand side is sine of 5 pi over 4 minus 5 sine of 3 pi over 4 plus 10 sine of pi over 4, and sine it's what, pi plus pi over 4 minus 5 sine pi minus pi over 4 plus 10 sine pi over 4. And if we want to represent angle which is greater than 90 degrees as in terms of acute angle from 0 to 90, there are the next rules, that sine of large angle should be represented as pi over 2 times n plus or minus acute angle from 0 to 90 degrees. And if n is even, it means it will be represented as pi plus minus something, or 2 pi plus something. Yes, it will be sine of just this alpha, and it doesn't matter, plus or minus is here. And finally we put a sign here according to what sign our original large angle has due to in which quadrant it is. And if n is odd, it means pi over 2 or 3 pi over 2, then it becomes sine, sine becomes cosine, cosine becomes sine. So here you can see that it's pi, it means n is 2, it's even, so it will be sine. Or you may remember, if we represent as some angle which is here or here, it will be n will be even, so it will be the same function, plus minus acute. If we represent as this plus minus acute, it n will be odd, and sine change, sine will becomes cosine, cosine becomes sine. So here it looks like sine pi, it's here, so it will be sine, and pi plus this original angle is in the third quadrant, where sine is what, y coordinate is negative, so final answer will be negative. So finally it becomes just minus sine of pi over 4. You may use any other rule as or due to symmetry as you like. Then minus 5, and again sine pi minus pi over 4 pi, so it will be sine, and original angle pi minus pi over 4, and original function sine, it's the second quadrant, it's positive, so it will be also positive sine of just pi over 4. This minus this sign doesn't matter. And plus 10 sine pi over 4, and you can see that we can add them up to get what? 10 minus 5, 5 minus 4 sine pi over 4, and 4 root 2 over 2. It's just sine of pi over 4, which is 45 degrees, and we get 2 root 2. So it seems to be correct. And you can see that the left hand side is equal to the right hand side. The next, I can delete it. The next, find the next integral, sine to the power of 5 from 0 to pi over 2. So definitely we should substitute this, and it becomes 1. So sine to the power of 5, it's what? It's just 1 over 16. We can write it in front of our integral. Okay, so it becomes integral from 0 to 2 pi sine to the power of 5 of theta d theta becomes 1 over 16 integral from 0 to 2 pi over 2, and sine of 5 theta minus 5 sine of 3 theta plus 10 sine of theta d theta, and is equal to 1 over 16, and integral of sine, it's what? It's negative. It's a negative cosine of 5 theta, and you may consider it as function of ax plus b, and you remember for integral 1 over a rises in front, so it's just 1 over 5, because in general you should do what? Substitution, substitution u, consider u to be 5 theta, and then you get just 1 over 5 in front. But its function, what does it mean? Sine of theta, and for example sine of a theta plus b, we apply the same formula as for just sine. It's integral of sine, it's negative cosine, but 1 over a rises in front. This plus minus b, it can be present or can be 0, it doesn't matter. You just keep given argument. So plus 5 and 5 over 3 cosine of 3 theta, and finally minus 10 cosine of theta, and limits from 0 to 2 pi over 2. And if we substitute the upper limit, you can see that it becomes what? 5 pi over 2, and it will be a multiple of pi over 2, and it's 0. 1, 2, 3, 4, 5. It's actually pi over 2, it's 0. And again 3 theta, 3 pi over 2, it's also a multiple of I mean that it will be here or here, where cosine is 0. So 3 times pi over 2, it's 1, it's 270, it's here, so it's 0, and cosine of pi over 2, it's here. So it's 0, 0, 0, 0. It's 0 minus, and we substitute the lower limit is 0, so it's and cosine of 0 is just 1, so it becomes negative 1 over 5 plus 5 over 3 minus 10. And it becomes 1 over 5 minus 5 over 3 plus 10. let's do a common denominator, which is 15. So it's what, 3 minus 25 plus 150, and it's what, 125 plus 3, 128 over 16 and over 15. Definitely it seems that it can be divisible by 16, but to avoid mistakes I will do in a few steps. So it's if we divide by 4, it's easy. It's 32 and 4, and again by 4, it's what, 8 over 15. 8 over 15. Then, hence, with reference to graphs of circular functions, find integral from 0 to pi over 2 cosine to the power of 5 d theta. Explaining your reasoning. Let's start with reasoning. Cosine looks like this, and from 0 to, let's show. So it's cosine, and from 0 to pi over 2, it's this region. It's cosine of x. And sine looks like this, and integral from 0 to pi over 2, it's area from 0 to pi over 2 between the curve and pi over 2. It's not necessary to sketch graphs and how to answer concisely. So we can say that cosine or graph, or just cosine, or a graph of cosine is sine shifted pi over 2 to the left. Is that for sine, graph like cosine theta, sine theta, graph of cosine theta is that for sine shifted pi over 2 to the left, and area for cosine from, or for x, or for theta from 0 to pi over 2 is area for sine for theta from pi over 2 to pi. It's this, due to symmetry. It's because graph for cosine and graph for sine, it's actually the same. It's the same curve, but it's just shifted. And due to symmetry, or we can say that area for sine theta for theta from pi over 2 from pi over 2 to pi is equal to the area for theta from 0 to pi over 2, and hence and we can say that integral integral is equal to area, and hence integral from 0 to pi for cosine to the power 5 of theta is equal to integral from 0 to 2 pi of sine to the power of 5 theta d theta, and it's the same answer, which is what, 8 over 15. Theta, something like this. So it's the required answer for this integral for cosine to the power of 5. And that's all for this question. Is equal to the area for is equal to the area for